Hey, what's up? We're going to do some lesson 10 homework help before the bell rings. Lesson 10, I don't know what page it is, you figure it out. I'll do one, you do the other. Identify the increasing and decreasing intervals. So on this function, I'm going to talk about function number one. I got my iPad right here that has a screen on it. Yeah, you get back to where you were. Screen lock that. Boom, done. Okay. So the thing with this question is that you need to identify where the function's increasing and decreasing, and by interval we mean like between what two numbers would the function be increasing or decreasing. But if I think about tracing this function here, it seems like it's always headed over and down. So for the person answering where this function is decreasing, number one, it's just decreasing on all real numbers. That means it's never increasing. The function always is over and down as we trace out the path. To identify where the function's positive or negative, that really means just where is the function above the x-axis. So it's kind of tough to see. It might help to sketch it out. Here's our x-axis, and in green, here's our y-axis. We can look at intercepts that way. It says identify the x and y intercepts where the function crosses those two lines. But to identify where the function is positive, we really just mean where the function is above the x-axis. And it looks like it goes this way to the left. So to answer the second statement, this looks like about 2, x equals 2. So the function is positive for all numbers less than 2. So for all real numbers less than 2. And the way that we can write that with notation that you're probably going to see is to say x is less than 2, or to say it this way, negative infinity, comma 2 with parentheses. That's what that means. That's why it's all the same color. To say where the function's negative means to go from that point beyond. So like right there. That's not a good differential color. Let's go right there. Oh, that's the bell. So I'm going to try to finish this one. Sorry for the bell being in your ear. Where the function's negative is everywhere else. So for x greater than 2, the function's negative. Or you could say from 2 to positive infinity. Same question, but maybe have like, some broken upness over here in this function. Okay, x and y intercepts. I mean, we've already talked about that, but if you can't list them as an ordered pair or just as a number, you need to figure that part out. On the next page, answer the following functions about the graph. This one we haven't really talked about very much. It's talking about average rate of change from x equals 1 to x equals 4. X equals 1 is right there, and when x equals 1, y equals 0. X equals 4 is right there, and so in that same spot, y, it's still on the x-axis. That also means y equals 0. So to travel from this function x equals 1 to this function x equals 4, there really is no up or down. Drawing a slope triangle turns into a flat line. So when we talk about average rate of change and we're talking rise over, but that's not the word run, maybe that is, we really mean that we're going to rise nothing and we're going to run 1, 2, 3 spaces. So 0 over 3. You can leave it that way, or you can simplify it. You could simplify it to say just 0. There is no rate of change. You should be able to identify the intercepts, write them in ordered pairs, so 0, comma, or something, comma 0. You need to have, like the structure of an ordered pair, and you fill in the numbers belonging. Name an interval where the function is increasing. To be an increasing section of the function means you have to go from low to high along some x values. So this looks like 1.5 to 2.5. Let's say from 1.5, comma 2.5, the function's increasing. You do the same thing for decreasing, but it's going in the other direction. So maybe like, there is a decreasing section of the function. What are the x values that correspond to point C and D? And you just put them like this. You could also, I guess, have written this way. 1.5 is less than x is less than 2.5. That's the other way to write an interval. Or describe it in words. Blah, 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 the 1.5 to 2.5, right? To be a relative maxima means to be the highest point of that section. So right there, A is the highest point in that section. B doesn't count. B is the lowest point in that section. C is the highest point. D is the lowest. So we could say A and C. List them. What are their values? A is at a value of, and C is at a value of. And then I'll leave you to do F because minima is the other side of the conversation. I think that works. Thanks. Bye. Thanks for watching. Like and subscribe. Pound it, noggin. See ya!